Welcome to the lesson for 8.3 for geometric sequences and series. This is the first installment. Just like we did with 8.2, we're going to figure out how to write a sequence that exhibit a geometric pattern and then look at, the different rules and applications. The definition for geometric sequence is that a sequence is geometric when the ratios of consecutive terms are the same. There is a number, it's called R. So when we divide out the adjacent terms, we get the same value, and this number is said to be the common ratio. And so this is how we determine if a sequence is a geometric pattern or not, by finding this R value, which is said to be the common ratio. So the common ratio, just like the common difference, we do the final value divided by initial. And remember, with the difference, it was final minus initial. So with the common ratio, it's final divided by initial. So if we wanted to look at some term values, we would do like a sub 5 divided by a sub 4. The nth term, how do we do the explicit pattern? So that's what it's telling you here. So the explicit rule for geometric sequences is a sub n is equal to a sub 1 times r to the n minus 1. And so if we're asked to write out the rule, this is what they're asking for. Okay. Geometric sequences and series exhibit exponential patterns. And so if you recall what an exponential pattern looks like for the formula, we would do y equals a times b to the x power. And of course, the a value is the y-intercept. And this is when x equals 0. And then the b value was either, the growth or decay rate. Okay, and so that's basically what you have to identify, and then you just put your rule together and go from there. Okay, looking at example 1, write out the first 5 terms of the sequence, just like we did before. Okay, so that's going to be step number 1. And then find the common ratio, so that's step number 2. And then write out the nth term, and that's going to be step number 3. Okay, well, let's go ahead and begin. So notice that they're giving us a recursion pattern, and the first term is given to us. So then the next term here, so k plus 1 is going to be equal to, and so that's going to give me a sub 2 is equal to negative 2/3 times the current, which was 36. And so notice the math there works out to be negative 24. Okay, next one, k plus 1 is 3. So a sub 3 is equal to negative 2/3 times negative 24. And so notice that that gives me positive 16. Next, k plus 1 is 4. And so we have a sub 4 is equal to negative 2/3 times positive 16. And so that's going to give me negative 32/3. So that's a great number. Okay, and then the last one here, the 5th term. So a sub 5 is going to be negative 2/3 times negative 32/3. And that's going to be positive 64/9. Okay, and so that gives me my first 5 terms. The first term was given 36, and then negative 24, and then 16, negative 32/3, and 64/9. Now you should be able to see that, in between each term, we're multiplying by the scalar of negative 2/3, and so that's what's giving you that common ratio then. Oops, that's step number 2. And so my common ratio here is negative 2/3. Now, if you couldn't tell that, you could just simply take the terms in the pattern, the adjacent terms, remember final divided by initial, and then, figure it out for yourself. But I think it's pretty obvious that it is indeed the negative 2/3. Okay, now the last piece is simply to put all the pieces together and write out the explicit formula. So a sub n is equal to the first term, which was 36, and then the common ratio is negative 2/3, and then the exponent here is n minus 1. Okay, moving on to the next page, they ask us to find the indicated term for the geometric sequence algebraically. Okay, looking at 2a, we have the first term is 5, the common ratio is 3/2, and they're asking us to find the 8th term, so we need to find a sub 8. Okay, first we want to write out the explicit formula. So a sub n is equal to the first term 5 times the common ratio to the n minus 1 power. And the reason we can do that is because they tell us that we have a geometric sequence here. Then we can go ahead and use that information and solve for the 8th term. So we're simply replacing n with 8. Okay, and notice that my exponent here is going to be 7. So then I'm going to get 5 times 3 to the 7th over 2 to the 7th. And then the 8th term here is going to work out to be 10,935 divided by 128. Now, looking at example B, this one's trickier. They give us the 3rd and the 5th term, and they ask us to find the 7th term. Well, let's just write out the pattern here to get an understanding of what they gave me. Okay, so I can see that my 3rd term here is 16/3. And then the next term, of course, would be the 4th term. I have no idea what that is. And then the 5th term, they tell me, is 64/27. Again, I don't know the 6th term, but then I am looking for the 7th term here. That's what I'm interested in. So in between adjacent terms, you're multiplying by r. That's how you get, on to the next term, if you will. So notice from a sub 3 to a sub 5, we would multiply by r, and then we'd multiply by r again. So we would multiply here by r squared. And notice it would be the same pattern between a to the 5th to a to the 7th. We would multiply by r squared. And so we're going to use that information and put it together. So we would know that a sub 5 then is going to be a sub 3 times r to the difference between the number of terms, which I know we identified visually, but I'm just trying to show you how you would do it algebraically, because if you have a big spread, you're not going to want to write out the whole list. Okay, so it's the difference between whatever the term positions are. Well, then we have a sub 5 is equal to a sub 3 times r squared. Okay, so r squared is going to equal a sub 5, which was 64/27, divided by a sub 3, which was 16/3. And so that gives me 64/27 times 3/16. So again, flip and I'll multiply by the reciprocal. And so then that reduces down to 4/9. And I don't really care what r is because I need r squared when I do my next step. So solving for r, you don't necessarily have to for geometric sequences. It just depends on what they are asking you to do. All right, so step number 2 is I'm going to kind of start off how I did here. So a sub 7 is going to be the 5th term times r to the 7 minus 5. And again, we're going to get r squared from that. So r squared, a sub 7 is equal to a sub 5, which was 64/27, times r squared, which we've already identified as 4/9. And then I just do my math there, multiply those together, and I get 256 over 243, and that's my final answer here. So depending on the information that they give you, sometimes we generate the explicit formula and sometimes we don't. It just depends on what we have and what we're trying to find. Okay, moving on to example C. So this is similar to the last one. They're giving us the 4th and the 9th term, and then they're asking us to find the 12th term. Okay, well, if we set up our formula here, I know that the 9th term would be equal to the 4th term times r to the 9 minus 4 power, which of course is 5. Okay, well, now I have r to the 5th is equal to 1/4 divided by 8. And so that gives me 1/4 times 1/8. So I have r to the 5th is equal to 1/32. Okay, so now I'm going to stop for just a minute. If I go on to my next step, and if I just tried to set up either of my terms. So if I did a sub 12 is equal to a sub 9 times r to the 12 minus 9, well, I would need r cubed here. Okay, so r to the 5th isn't going to help me. Well, what if I try my other one? Well, my other term that they gave me was the 4th term. So if I did a sub 12 is equal to a sub 4 times r to the 12 minus 4, notice that would give me 8. So here, see, we've got a little different situation here because I don't have the power of r like I did on my last one. So in this case, I do need r. I need to find the r value. Well, in order to do that, we're going to go ahead and take the 5th root of each side. And so r is going to equal the 5th root of that is 1/2. Okay, now I can use, either my first version or my second version. It doesn't matter because I have my r value. I'm going to use the first one. Okay, so the 12th term here is going to equal the 9th term, which was 1/4 times r cubed, and I just found r to be 1/2. So then we get 1/4 times 1/8. And so my 12th term here is 1/32. And that is my final answer. So again, notice that on the last one, we didn't need the explicit value for r, but on this one we did. And that's because of the given information. So, just kind of be aware. Sometimes you'll need it, sometimes you won't. Okay, looking at the last example here, we've got a sub 4 is equal to 128 over 375. A sub 7 is 8192 over 46,875. Wow, these are big numbers. Okay, and then they're asking us to find the first term here. Okay, so step number 1, a sub 7 is going to equal a sub 4 times r to the 7 minus 4, which of course is going to be r cubed. Okay, so r cubed is going to equal 8192 divided by 46,875, and then I'm going to go ahead and flip and multiply. So we're going to have 375 divided by 128, and then this actually reduces really nicely. It reduces down to 64 over 125. Now, if I need to, I can take the cube roots of both sides, but I'm just going to pause for a moment and see if I need to or not. Okay, so now if I wanted the first term, I'm going to use a sub 4 is equal to a sub 1 times r to the 4 minus 1 power, which is r cubed. So again, I don't even need to find the r value. R cubed is perfect. So then that means that a sub 1 is going to equal a sub 4, which was 128 over 375. And then I'm going to divide by r cubed, which is 64 over 125. And so a sub 1 is 128 over 375 times 125 over 64. And that gives me then the first term value to be 2/3. And that is my final answer. Okay, so again, could we have found r? Sure, we could have found r if we wanted, but we didn't need to because of the terms that they gave us. Okay, notice on example 3, they're asking us to find a formula for the nth term of the geometric sequence, and then find the indicated term. Okay, this one's actually pretty straightforward because they're giving us the sequence. So firstly, we want to find the R value, and they already tell us that it's geometric, so I don't have to like do a bunch of guessing and checking. I can just go right to the fact that the common ratio here would be found by taking a sub 2 over a sub 1, and that gives me 12. Again, note that the first term here is 3, and so I can state my explicit formula right away. A sub n is equal to 3 times 12 to the n minus 1, and then I can go ahead and find the 7th term. So a sub 7 is equal to 3 times 12 to the 7 minus 1, and you would want to go ahead and put that in your calculator, and we would get 8,957,952. Alrighty, that concludes the lesson for the first installment here for 8.3. Tomorrow we're going to look at the series and when we can find the sum for those series. So please make sure to look at Canvas to determine your homework assignment and get that submitted, and let me know if you have any questions.